Today we're going to start looking at the vocabulary of algebra essentially, and we're going to start with some just basic vocabulary. The first one is variable. A variable is a letter or symbol that can stand for any number. You have probably seen this before in terms of when you were in early elementary, you might see something like this. And the question mark in that case would be your variable because it's a symbol that stands for a number. We don't know what number it stands for. Now in this case we could figure out that the number it stands for is 3, but it could stand for any number because, for example, I could have an expression that looks like this. Now in that case the question mark stands for 8, so its value can change. Now, as we move away from elementary school toward middle and high school, variables are not going to look like symbols generally. They're going to be letters, so it's going to look something more like this, m plus 4, where m would be your variable. Then another word you need to know is constant. Since a variable is a value that can change, a constant is a value that does not change. In other words, it's just a number that has to stay the same. So if we're looking at an expression, for example, 7 minus r. In that case, r is a variable, but 7 is a constant. R is a variable because we don't know what r is. It can really be any number we choose for it to be, but 7 is 7 is 7 is 7. Its value is not going to change, therefore it is a constant. A coefficient is a special kind of constant. It is a number that is multiplied by a variable, and it's always written in front when the operation sign is not used. So an example of that is, for example, 4x. In that case, x is a variable and 4 is a constant. But 4 is actually a coefficient, which is a special constant. But it's a coefficient because what this really means is 4 times x. So the coefficient is the number that's written with the variable that the variable is being multiplied by. And again, it is a constant. It's going to be a number, and it could certainly be a fraction. It could be a decimal. It could be a negative number. But it is a number that is multiplied by a variable. It's always going to be written in the front if there's not an operation sign. Some other vocabulary you need to know is the word expression. An expression is a mathematical statement. It does not have an equal sign. So, for example, this is an expression, 4 plus 5. Another expression is 10 minus 1. Those are both expressions. Now, these two happen to be equal. If we put an equal sign between them, now we have one big equation, which we'll talk about in another lesson, but that is not an expression when we put the equal sign in between them. Or if we were to put 4 plus 5 equals 9, that is also not an expression. That is an equation. So an expression is just the mathematical statement, but without being told what it equals. A numerical expression is one like the examples I just gave you. It's an expression that has numbers. It may also have operations. So, for example, 3 plus 7, 12 divided by 4, 2/3 times 1 1/4. Those are all numerical expressions. And I could have as many operations as I wanted. I can even have exponents. So, for example, 7 squared. That's a numerical expression because it has numbers and it can have operations in it as well. An algebraic expression is similar. The difference is it's an expression that has at least one variable. So in addition to having numbers and operations, it can also have a variable. So for example, we could look at something like x plus 4, 3r minus 7. Those are algebraic expressions because they have variables. So when we look at some examples up here, we can see some numerical expressions. Again, they're numbers, they have operations, there can be more than one operation. So it's just going to have constants and operations. When we look at algebraic expressions, they're going to have constants. They can have constants. They can have operations, but they're going to definitely have variables. Now, just to take a quick peek at when we look at this, 7h, the 7 is a coefficient, and 7h means 7 times h. M divided by 9, of course, means m divided by 9. We could also write this as in fraction form. ABC means A times B times C. So when I have numbers next to each other, or variables next to each other with no symbol in between, that is a multiplication. And then our last example, 3 times the sum of x and 4 is an algebraic expression because we have a constant 3 and we have, in fact, we have two constants. The 3 and the 4 are constants and the x is a variable. Now notice in this case, we also could really look at the 3 as a coefficient because it's being multiplied by the x plus 4. The other piece of this that we can look at is we can say, the other thing I want to point out to you is we could look at this as having two factors. 3 is a factor, and also x plus 4 is a factor. So notice that a factor does not have to be just a number or just a variable. A factor actually can be an expression of its own. So an algebraic expression, or a numerical expression for that matter, can itself be a factor depending on how it's written. Because the two things being, factors are things that are being multiplied. The two things being multiplied here are 3 is one of the factors, and x plus 4 is the other factor. So take a minute now and see if you can place these expressions based on where they belong, what kind of expressions they would be, numerical or algebraic. Pause while you do that and then hit play when you're done. Okay, if you have done this correctly, these should be your numerical expressions. You should have these 4. And all of the others are algebraic expressions. Remember, what makes them algebraic is the fact that they have at least one variable. So algebraic expressions must have a variable. Numerical expressions do not have a variable, and that's the biggest difference. Now, algebraic expressions, what do we do with them? Well, we evaluate them. Remember, we've talked about the word evaluate, and it means to solve, to find the value of. And the way that we evaluate an algebraic expression is we plug in a number for the variable, and then we solve it. So in this first example, 3r plus 1, and we're solving it for r equals 6. What that means is we're going to put a 6 where the r was, and then we're going to solve it. So when we do, we're going to do 3 times 6, which is 18, plus 1, which is 19. So the value of 3r plus 1 when r is 6 is 19. Now, the question sometimes comes up, why is r 6? What's the reason for r being 6? And the answer is, because I said so. I could pick another value for r if I wanted to and evaluate it for, let's say if I wanted to evaluate this one, if r equals 9, I could do that. 3 times 9 plus 1. That's going to give me 27 plus 1, which is 28. And it doesn't even necessarily have to be a whole number or a positive number for that matter. If r equals 4/5, for example, that would mean 3 times 4/5 plus 1. 3 times 4/5 is 12/5, which is 2 2/5. 2 2/5 plus 1 is 3 2/5. So understand that it truly just means whatever value a variable is assigned, you're replacing the variable with that value and then solving. So let's look at a couple more. Let's solve a over 2 minus 3 for a equaling 16. So if we put a 16 where the a was, that's going to mean 16 over 2. Remember, 16 over 2 means 16 divided by 2, which is 8. 8 minus 3 is 5. All right, our next example, 6 plus s times 5 for s equals 2, and then 8 plus ab for a being 6 and b being 3. Notice we can have more than one variable. That's okay. As long as we know the values of the variables, we can evaluate the expressions. Take a moment and try both of these and pause while you do it and then check your work. Okay, so for the first one, 6 plus s times 5, we're going to end up with 6 plus 2 times 5. Now, remember, we still have to use order of operations. Sometimes kids will say, I didn't know I had to do that. We're not studying that. Well, order of operations doesn't live in a bubble. We don't just do it during a time that we're studying it. Order of operations always exists, and it always must be followed. So we have to do the 2 times 5 first, which is 10, and 10 plus 6 is 16. For the next one, 8 plus AB. This one is going to be 8 plus 6 times 3. Remember, a variable next to a variable with nothing in between means to multiply. And some people will say, well, I thought it meant 63 because A is 6 and B is 3, so it's 63. No, that's not what it means. If I wanted to make it 63, I really only need one variable because a variable can be a multi-digit number. That's okay to have. So it does not mean 63, it means 6 times 3. As I work that out, 6 times 3 is 18, and 8 plus 18 is 26. All right, try each of these, see what you come up with, and then you can check your work in just a moment. Okay, S minus T would mean 12 minus 3, which is 9. 3S minus 4R would give us 36 minus 24, which is 12. 3RT minus S would give us 3 times 6, which is 18, times 3, which is 54. And then 54 minus 12 is 42. S minus 2R divided by T. So we would have to do the 2 times R first. That would be 12. And then 12 divided by 3 is 4. And 12 minus 4 is 8. The next one, 3R squared. Notice if you do that one, R is 6. When we do that one, we're going to have to do 6 squared to begin with because exponents come before multiplication in order of operations. 6 squared is 36, and 3 times 36 is 108. And last but not least, 4 plus 2R. R is 6, so 2 times 6 is 12. 12 plus 4 is 16. All right, now let's take a quick peek at these and see if we can come up with what our mistakes are and how these have been worked out. So in this case, we have 18 over h plus 5. We know that h is 6, and we've got, so if we put it, they did put a 6 where the h was, so they've done that correctly. And then the next step should have been the 18 divided by 6. Oh, wait. There's our mistake. They didn't do 18 divided by 6. They did 18 minus 6. But remember, that's a division bar. So what should have happened is 18 over 6 plus 5, they should have gotten 3 plus 5, which is 8. And looking at one more example of that, RM minus 5. Now, if we go back up, we see that R is 2 and M is 4. So when we come back down here, notice what they did. They made it 24. They should have made it 2 times 4 minus 5. 2 times 4 is 8, minus 5 is 3. All right, hopefully at this point you have had a good explanation of and understanding of evaluating expressions, and you'll be ready to soon, very quickly, move on to working more in depth with expressions.